What's going on, everybody? Mr. Diamond back from lunch, just in case I have any gross things on my face. Hopefully not. But we're going to get through basics of motion is what we're going to talk about today. We're not going to get through the whole section. We're just going to get up to talking about speed and velocity, I believe, is where we're going to go to. So the first thing I want to talk about is distance and displacement. And these two words sound really similar, and you probably think that they mean basically the same thing. If this was moved a distance of 5 feet, it was displaced 5 feet. But in reality, and this is going to become a trend in this class, they mean very different things in physics. Distance is the full, I know I'm using the word in the definition, but the full distance traveled by an object from the start to the end position of a trip. It is the full journey that a trip has made. While displacement is the distance between the start and the end point of an object, regardless of the path taken to reach that location. So if you're still confused, an example will probably help. I'm going to do the example that's on the next slide, but I'm also going to use my trusty pencil right here. So let's say, for example, that this pencil goes on this journey. It goes up, over, does a big loop-de-loop, and then comes back to its starting position. The distance traveled would be the measurement of all of the motions that it made in that full journey. We'd calculate how many meters or how many centimeters it traveled in total, and then that is the distance that that object has traveled. Displacement, if it started here, did all that stuff, and ended back here, is 0. The distance between the start and the end point, regardless of the path, is displacement. Another way to think about it would be if I'm traveling from here to here and I'm going up and down a bunch of hills, the displacement would just be this straight distance measured from start point to end point, while distance would actually have to account all of the ups and all of the downs that were traveled. Now, and another example of this, actually using some calculations, would be a man moves from point A to B, then B to C, and then C to D. Find the distance and the displacement traveled by this man. So if we go to distance, we just need to calculate all of the stuff he's moved. This is a full rectangle here, so that's 50 plus 30 is 80, plus another 50 is 130. I hope I did that math right in my head. So 130 is the distance traveled, but the displacement, if you just go from where did he start to where did he end, is only 30 meters. So those two are very different numbers because displacement only cares about, well, where did you end up? Distance cares about the journey along the way. Now, the other way to describe this or to think about them is that displacement or distance is a scalar, while displacement is a vector. And we're going to be using both of these ideas quite a bit through the year, so this is a good time to get them out of the way. A scalar is a quantity that has a magnitude but no direction. So, for example, I walked 3 miles yesterday, while a vector is a quantity that has magnitude and direction. It's usually represented by an arrow, as you will see if you click on this beautiful video. We're not going to watch the full thing, but you may have seen a little movie called Despicable Me, where the villain Vector, I will put on subtitles because I don't know how this is fully going to work with you being able to hear it or not. So he's applying for his new villain loan, Vector, and he actually has the pretty accurate definition of what a vector is. If we give him a moment. Mathematical term, a quantity represented by an arrow with direction and magnitude. That is a vector. Vectors have direction and have magnitude. So, for example, instead of just saying I walked 3 miles, you say I ended up 3 miles south of my campsite. 3 miles is the magnitude, south is the direction. If we go back to distance doesn't care. It follows the journey, but it just tells you a magnitude, a distance. Whereas at the end of it, going back here, the distance, again, I try to point to the screen, the distance of 130 for this trip right here doesn't have a direction. It just says, oh, he walked 130 meters. But the displacement would be 130, or would be 30 meters north, if we're assuming that this is north, south, east, west. So 30 meters to the north would be his displacement because it has the magnitude and the direction. So that brings us to velocity versus speed. Now, these terms even more so, I assume you've used relatively interchangeably in the past when you've heard about them. What is the velocity of that? What is the speed of that? Those of you that are Monty Python fans, what is the airspeed velocity of an unladen swallow? All of those kinds of questions, you usually can kind of use them back and forth. And I will honestly probably make the same mistake, and I will accidentally use them interchangeably in this class as well, because I am not perfect, contrary to what you may be looking at for you, the perfect human being. Velocity is a vector. It is the displacement of an object divided by the time that it took for that displacement to occur, where speed is the distance an object traveled divided by the time that it took for it to occur. That one is a scalar quality. Or quantity. Why is that? Well, I'm sure you can probably put two and two together. Because displacement is vector, or is a vector quality, velocity, because it's based on displacement, also must be a vector quantity. You must say, okay, it's going this velocity, it has this amount of distance that it will cover over this length of time, and it will be pointed a direction. It will be 30 meters per second north, or 25 meters per second southeast, whereas speed is just 30 meters per second, distance divided by time, as opposed to displacement divided by time. So this is the key idea between velocity and speed, and between vectors and scalars. Now, I think we're going to go back to this example, and we're going to assume it took this man 5 minutes to walk this route. 50 meters, 30 meters, 50 meters. So his speed would be, if we calculated the full distance, so 50 plus 50 is 130, plus 30 is 130, and then we divided that by 5. And we're going to put this into seconds, because meters per second is the most common one we're going to use. So we're going to go 130 divided by 5 minutes times 60, divided by 5 minutes times 60 seconds, 1 minute. That would be divided by 60. There we go, divided by 60. So it looks like we're going 0.43, according to my calculations here. Meters per second is the speed, but velocity, he's only moved 30 meters. So 30 meters divided by 5 and then divided by 60. His velocity is only 0.1 meters per second north. 0.1 meters per second towards the vertical, again, I point to the screen, towards the vertical portion of the screen. You have to include the direction that it's going, as well as the distance over time portion, what we would normally think of as the speed. Basically, velocity is speed plus a direction. You can almost think of it that way. Again, speed technically is distance, but it gets a little bit confusing to actually use the terminology, because we just naturally go to speed and velocity just like we naturally went to distance with the other one. But you can almost think of it that way. So that brings us to enough background where now we can actually get into 1D kinematics. You guys are going to have a lab where you're going to be using Google Maps, which is going to be kind of interesting. I'm going to show you actually kind of how to do that here. So we're going to go to Maps, Google Maps. And let's say that I wanted to know how to go from Ciros in St. Genevieve to, let's see, we're going to do directions from Ciros, and we'll start at St. Gen High School. Now, what it's going to show us right now, this trip right here, is the trip that we would actually be taking. We would be going 0.7 miles, according to this, 0.7 miles and 4 minutes. That is the distance we will travel, and that is the time it will take to do that. So with those two pieces of information, you can now figure out the speed. If you want to know the velocity, you need to know the displacement. So what you're going to do is we're going to click here, and we're going to measure distance, right-click, and then put a measure distance pin at the St. Genevieve Elementary School. I know we did high school, but... And then we're going to go over here and click on Ciros, right-click, distance to here, and now it will actually tell us total distance is 677.76 meters. And you should actually be able to change the If we go here, we can do options, we can do kilometers, and we'll actually tell us how many meters instead. So that's 1.2 kilometers of distance we're going to travel here. And this one, we're not even going to travel a full kilometer. The actual displacement from the start and the end of the trip is only 677.76 meters. So using that, you can calculate the velocity instead of the displacement. Now, just in case you're also confused by some of these other things, you do also have the option of doing walking, biking, stuff like that. And notice that walking will actually change. It will make the time longer, but it will usually make the distance shorter. In this case, the displacement shorter. In this case, we're going 900 meters instead of the 1.3 kilometers, but it's still going to be as the crow flies, as old people might say. This straight line is going to be significantly shorter. So that's what you're going to be using to find that information. It'll be going all over different things in Google Maps. You'll be able to do a lot of it at home. You'll also be able to do a good chunk of it in class, those of you that are not on AMI. I hope that makes sense to you. I hope you guys have a great rest of your day. If you have questions, as always, feel free to put them in an email. You can pop into a Zoom and ask them. Either way, this is Mr. Diamond signing off. Have a good rest of your day.